Welcome to my session, Fabrics Dance with Data alongside Excel and Power BI. My name is Henk Vlootman and I have the honor of being yearly awarded with the Microsoft MVP Award in the category Data Platform since 2013. I'm the founder and CEO of Quanto, a company focused on collective analytics in Power BI and Fabric. I also enjoyed writing books and I'm currently working on one about extreme DAX, data analysis expressions. I'm excited to share my knowledge with you today as we explore the powerful synergy between Microsoft Fabric, Excel, and Power BI in shaping the future of modern business data-driven insights. Fabric is Microsoft's new data platform introduced in 2023, making it a cutting-edge solution for modern business analytics. Designed with data analytics at its core, Fabric is the perfect tool for businesses seeking to harness the power of data insights. Fabric's main goal is to collect all data and transform it into a single format, Delta Parquet tables. This format is optimized for visualization tools like Excel and Power BI, which makes Fabric ideal for advanced business users looking to derive insights from their data in a uniform structure. Fabric is sometimes compared to the traditional databases. It's important to understand the difference between databases and Fabric. Although the output from Fabric may resemble a SQL database tables, the underlying structure and functionality are quite distinct. Relational databases, like SQL, are designed for transactional data management, using a rigid structure of dimensions and fact tables ruled by relationships. In a SQL database, you cannot record a sale for a customer that does not exist in the customer dimension table, thus ensuring structural integrity in the data. Fabric, on the other hand, can for instance store data in what's called a Lakehouse, typically using a table structure. These tables differ in how they handle data compared to a traditional database. Later in this session, we'll explore the key differences in greater detail, helping you to understand how Fabric is reshaping the landscape of data management. In today's world, there are significant challenges related to data, and Microsoft Fabric is designed to address these issues effectively. First, the volume of data is growing exponentially. Back to the 80s, when personal computers began making their way into businesses, spreadsheet programs like Lotus 123 could handle around 8,000 rows. In contrast, modern business users can work with millions of rows in one table. Also, data entry has evolved. Early spreadsheets required manual input because a personal computer was truly personal. Networks did not exist yet. Today, data is largely collected in a more automatic way, vastly improving efficiency and reducing manual errors. Second, with the advent of networks and the internet, users now have access to different data sources. However, data is stored in various ways, depending on the platform. For example, SAP stores data differently than a SQL database. This creates data silos where each platform's data is confined to its own environment. To gain cross-company insights, modern data analytics requires combining data from these separate silos. First, before Fabric, companies typically built enterprise data warehouses to consolidate all data stored in silos into a new single database silo. While this helped centralize information, it also led to inefficiencies. Most of the planning in relational structures requires a lot of time before seeing any benefits, resulting in high costs before even any data is available. Additionally, the rigid structures ruled by relationships imposed by the traditional database makes it difficult to work with unstructured or semi-structured data, limiting flexibility. Fourth, databases were traditionally created and maintained by IT specialists, giving them access to all data. This exposed security challenges when business users needed to access specific data, as they might be exposed to all data, including sensitive data. Solutions like a data mart are developed to create subsets of data for specific roles. But data marts are expensive in design and lack the need of flexibility and therefore hard to maintain. Fifth, traditional shaped relational databases, while unproven solutions for storing and management data, are not equipped to handle model analytics demands in an efficient and cost-effective way. The rigid structures and high costs of traditional systems are no longer suitable for the fast-paced, flexible data analytics required today. Sixth, finding expertise in data collection and analytics is difficult and expensive, which is why Excel remains such a popular tool. When IT or business departments are often unable to deliver the insights the business user needs due to the high request of dashboards. So business users tend to turn to the tools they are familiar with, like Excel, to perform their data analysis. Microsoft Fabric seeks to solve these problems by providing a more scalable, flexible, and efficient data platform. It allows for easy integration, centralized data management, and is built with the needs of modern business analytics in mind. Traditionally, data collection has been done using relational databases, which relies on a schema-structured approach that can be compared to a well-organized drawer on the left. This is known as a schema-first approach, and in contrast, the right drawer represents a more chaotic scenario. At first glance, it appears messy and lacks the structure in the left drawer. This flexible, less structured approach is called the data-first approach. And our next two slides explain these basic concepts. Schema first has several advantages, particularly in a context where structured, reliable, and efficient data storage is crucial. Here's why this approach is favored in database scenarios. The key benefit of schema first is its highly structured nature. Data is stored in an organized, predefined way, which ensures consistency and clarity across the data. Every table, column, and relationship is clearly defined, making it easier to manage and navigate the data. Another benefit of the schema is defined in the advance. It means that the underlying storage is optimized for fast writing to the hard disk. This makes it particularly well suited for transaction processing, where high volumes of data, changes, the transactions, need to be recorded quickly and efficiently. Also, the relationships between tables are predefined, often reflecting man-made decisions about how the data should interact. This enabled control calculations and operations between related data points. For example, foreign key constraints help maintain data integrity by ensuring that relationships between tables remain valid. The predefined schema gives a clear understanding of how the data is structured, which makes acquiring and reporting more predictable. However, there are also some drawbacks. One of the biggest downsides is that all tables, whether they are actively used or not, must be included in the schema. This can lead to high developer and maintenance costs, and unused tables still take up space and resources. Furthermore, because the schema is rigid, adding new data sources or adapting to changes can be cumbersome and expensive. Another drawback might be the way data is collected. Different databases create different silos that cannot easily communicate with each other. Delta Parquet files in a data lake are designed for fast aggregation of large data sets, which is crucial for BI applications, where summarizing and analyzing data across millions of rows is common. This makes it efficient for use in analytics queries and reporting, where aggregations like sum, average, and count are frequently performed. Fabric converts all formats into one format. It simplifies the process of integrating data from various systems, e.g. SAP, SQL, etc. This uniformity benefits Microsoft BI tools like Power BI, Excel, and Fabric, allowing them to process and analyze data seamlessly across multiple platforms. Suddenly, data can communicate with each other. Unlike traditional databases that require rich schemas, data lakes can store the tables and data needed for a specific BI project with or without relationships. This results in lower costs as you are not maintaining unused tables or paying for excessive storage. It makes it a cost-effective solution for businesses, particularly in the context of growing data volumes and the need of quick insights. It also provides greater flexibility because new data sources can be added or removed without the need for restructuring. Overall, data lakes provide an agile and scalable environment, particularly suited for BI tasks, by offering efficient storage, ease of integration, and cost savings. I am not saying that you should choose between databases and data lakes. Each has its own dynamics and use. It's time for a demo. We head over to Fabric, create a workspace, and set up a Lakehouse to store our data. Keep in mind, you might not have the required permissions to complete the steps in this demo yourself, which is depending on your organization's policies. If that's the case, reach out to the admin or owner of the workspace or Fabric environment, because they are responsible for managing rights and access, and they can provide the necessary permissions or assist with the process. Let us now dive into the demo and see how we can build this data solution step by step. The first thing which becomes visible when opening the former Power BI services is the Fabric logo. When the Power BI logo is visible at the bottom left of the screen, it's indicated that Fabric is currently in the Power BI mode. This means the environment prioritizes Power BI functionalities, though most of Fabric's broader functions are still accessible. Fabric offers multiple modes, such as Power BI, data engineering, and others, each catering to the different users' needs. Switching modes allows users to prioritize the functions relevant to the selected mode, making it easier to focus on tasks related to that area. However, core features of Fabric always remains available in each mode. Some Fabric features are tailored for professional IT employees with expertise in advanced data management and engineering. But other features are more intuitive and useful for Power BI Excel and Power BI users. These users tend to work more with data visualization, analysis, and reporting. I'd like to give you just one tip. The data activator, in my opinion, plays a critical role for both Power Excel and Power BI users. It likely provides an interface and functionality that facilitates data-driven actions, such as triggering workflows, alerts, or real-time data insights, which are relevant to data professionals and Power business users. We take a small tour on two functionalities that, in my opinion, are useful for Power business users. By accessing the OneLake Data Hub, users can easily navigate through their various data sources, making it simpler to manage and explore the data assets. The monitor feature is crucial for maintaining the accuracy and timelessness of data, especially when working in environments where reports and dashboards rely on frequent data updates. The Monitor button provides detailed insight into ongoing and scheduled processes, automatic processes that update datasets. It helps users track and monitor all the refresh activities in their workspaces, ensuring data is up to date. We are now going to create a new workspace in Fabric. In the left navigational pane, locate and click on the Workspace button. This will display a list of existing workspaces. Next, click the New Workspace button at the bottom of the Workspace panel, and this will open a new window titled Create a Workspace. In the name field, type EVG2024 as the workspace name. This will help you identify the workspace easily. You also have the option to assign an image to the workspace, and this image will serve as a visual identifier to help you recognize the workspace briefly. Click on the image placeholder or on the plus icon to upload a custom image from your local files. At this point, you may also want to configure access permissions. You can add users or groups to the workspace and assign roles such as admin, member, contributor, or viewer. The specific details of role assignment are subject for another session, since careful considerations is needed to manage access and permissions. After these steps, click Save or Create to finalize the creation of the workspace EVG2024. Now you have a clearly identifiable workplace with ready for data collaboration and reporting. Next, we create a Lakehouse. In your workspace, in this case EVG2024, find the plus new item button at the top of the screen. It displays all the available options for creating new items within the workspace. In the Store Data section, click on the Lakehouse button. Selecting these options will automatically upgrade the workspace to a Fabric workspace, enabling all relevant Fabric features. When prompted to name your Lakehouse, follow the naming convention using a prefix for easy identification. In this case, enter LH_EVG2024, where LH_ is our prefix. This will help distinguish the Lakehouse from other assets in your workspace. Once you confirm, the Lakehouse will be created. It serves as a scalable and structured storage environment, allowing you to store large data sets for analysis and aggregation. In the next demo, you will see how to add data to this newly created Lakehouse, transforming it into a repository for data that can be used for aggregations, data transformations, and BI analysis. Now you have a glimpse of Fabric, you might wonder, why should you, as Excel or Power BI user, explore Fabric? The answer is simple. In Fabric, data is basically stored in a data lake, and flexibility of this environment allows virtually any kind of data to be stored. This is a huge advantage for business users, as you can consolidate data from diverse sources into uniform tables. This uniformity gives you complete control over your data, which is crucial for data consistency and management. Let's dig into this a little bit more. Consider this scenario. You have created a powerful Power Query script in Power BI for transforming data in your model. Now you want to use the same transformation in another Power Query script within Excel. Without Fabric, you need to duplicate the script, and that means maintaining two separate versions in both Power BI and Excel. An inefficient and error-prone process. However, by placing your script in Fabric and adding the table to a Lakehouse, you centralize your data transformation. Both your Excel and Power BI models can be connected to the same table in the Lakehouse, meaning you only maintain the script in one place. This streamlines your workflow, reduces duplication, and ensures that any update or changes you make are reflected across all connected models, and thus creating one source of the truth. In short, Fabric enables you to scale your data works across different business platforms with centralized management and easy integrations, making it a valuable tool for any Excel or Power BI user. There is some real magic in how Microsoft handles data storage in data parquet tables. To refresh your memory, as said before, traditional databases store data based on transactions, meaning data is randomly written to the disk. In contrast, Delta Parquet tables are stored in a columnar format, much like how data is structured in Excel's Power Pivot or Power BI's semantic model. This columnar storage method, combined with Microsoft's advanced data compression techniques, makes Fabric incredibly fast. It enables users to handle massive data sets, often in the range of millions of rows, with ease. For example, working in millions of rows in Power BI is not only possible, but it's the norm. In fact, I have run tests with 25 million rows in a single table, and the response time was when using Power BI visuals was shockingly fast. One of the reasons for this speed is that Microsoft partitions the data into multiple parquet tables, allowing it to be processed in parallel, further improving performances. This means large data sets will be sliced, processed, and visualized much more efficiently than traditional row-based storage systems. Another interesting development is how open Microsoft has become with its data standards. In the late 20th century, like many other database providers, Microsoft was quite proprietary with its standards, making it hard to access or create data files outside of their own products. But now, Delta Parquet tables have an open structure, meaning you can access and work with them using other programs, not just Microsoft products. This openness offers a lot of flexibility. allowing businesses to integrate and process data in various environments. Now, let's have a look at a scenario in which Microsoft Fabric is being used for data storage and modeling, with a focus on simplicity and flexibility. Let us break this down to understand the key ideas. In Fabric, data storage in a Delta Parquet tables doesn't necessarily require relationships between those tables. This is a data-first approach, meaning you will store data without predefined structural constraints. The guiding principle here is minimalism. Only add relationships where they provide actual value. While the data itself may not have explicit relationships, they can be established later in tools like Excel Power Pivot or in the Power BI semantic model. This means that the structure of your data model can be defined at the reporting or analysis layer, rather than hard-coded in the lakehouses. But if you wish so, you can create relationships in your lakehouse and create a full functioning SQL database structure. You really have flexibility modeling at your desk. One of the significant advantages of lakehouses is its agility. You can pull in the necessary tables from your model and work directly with them, adding new tables as needed. This reduces overhead, as you don't need to worry about managing complex data architectures at the storage level. Because Lakehouses simplifies the process of managing and modeling data, it can also lead to faster development times and lower costs. And this is especially beneficial for business users seeking agility in their data operations. Lakehouses could replace traditional enterprise data warehouses. As said, traditional data warehouses tend to have a lot of overhead in terms of architecture and governance. Lakehouses, with its flexible, decentralized, and on-demand approach of data modeling, may be able to provide similar insights with less complexity. In summary, Lakehouse's data-first approach promotes simplicity and agility, where you focus on pulling the necessary data in your model for analysis, rather than worrying about underlying database structures. This can accelerate project timelines and reduce costs compared to traditional data warehousing methods. In business analytics, most data you retrieve isn't immediately ready for analysis. It typically requires some level of transformations to make it useful. For example, if you're working in Excel with a table containing dates, you might need to add a new column that extracts just the year from each date. This column helps you to filter and analyze data based on years. That process, adding a year column, is an example of data transformation. This concept of transforming data is part of a broader process known as ETL. In Microsoft's data ecosystem, mind you, this includes Excel, Power BI, and Fabric, the ETL process is carried out by a tool called Power Query. Power Query allows users to connect to various data sources, apply transformations, and load the clean data into models or reports. It uses a language called M to define these transformations. In Power BI and Fabric, Power Query is embedded within an app called DataFlows. DataFlows are designed to serve as a self-service data preparation layer, allowing users to transform data without the need for IT or data engineering teams to be deeply involved. Here is how the ETL concept works in Fabric. Extract. You import data from various sources such as databases, cloud storage, flat files, API calls, etc. In the transform layer, you use Power Query within DataFlows. You clean, filter, and reshape the data to fit your analytic model. This step can involve splitting columns, aggregating values, or edit calculated fields. The last one, load. Once the data is transformed, you save the resulting table in the cloud for use in analytics model or business intelligence reports. DataFlows simplifies the data preparation process by allowing you to automate these steps, ensuring your data is always up to date and consistent. This makes it an essential tool within the Microsoft Fabric, Power BI, and Excel ecosystems. DataFlows offers a flexible self-service environment for performing ETL, making it easier to prepare data for business analytics. In Microsoft Fabric, the DataFlows are powered by DataFlows Gen2. This app retains the familiar look and feels of Power Query across Microsoft data ecosystems, such as Excel and Power BI, and of course the first version of DataFlows. But it also introduces several enhanced features specific to Fabric. Along these options, the Lakehouse is especially interesting for Excel and Power BI users. The Lakehouse combines the scalability of a data lake with the structure of a warehouse. This means you can store both unstructured and structured data in one place and then use Power BI or Excel to easily query and analyze it. Excel and Power BI users can seamlessly connect to the Lakehouse, reducing the complexity and integration of different storage systems, and make it easier to work with large data sets without performance bottlenecks. The main idea behind DataFlows is to create reusable tables that can be accessed by tools like Excel and Power BI. Instead of having multiple sources of data in different models, DataFlows allows multiple models to pull from a single shared table, ensuring you that you use the same source consistently. Originally, first-generation DataFlows allows this for shared table functionality, but they had a limitation. They couldn't write tables to a central data storage system like a Lakehouse. With the introduction of DataFlows Gen2, you gain the ability to write tables directly to a Lakehouse. Additionally, DataFlows Gen2 allows you to incorporate those tables into a semantic model, which gives you more control over the relationships between the tables. This ensures better integration and management of the data across various tools.
Here's a step-by-step guide for importing a text file into a Lakehouse using DataFlows Gen2 and transform it into a Delta Parquet file. We also cover copying a Power Query script into DataFlows Gen2 and update the data in the Lakehouse. Now let's walk through those scenarios and start with upload of a text file. In the Lakehouse, for the EVG2024 workspace, click the Upload Files button. In the dialog box, find the text file, e.g. verkoop.txt, and you want to upload and select Upload. This will import the file into the file section of the Lakehouse. Wait for the upload to be completed. It may take some time. Now we create a DataFlows Gen2 for changing the text file verkoop.txt into a Delta Parquet table. We start in the workspace EVG2024. Click on plus new item and select DataFlows Gen2. Make sure to avoid selecting the DataFlows Gen2 as the Gen1, which doesn't say Gen1, lacks the ability to write to a Lakehouse. In the DataFlows Gen2 editor, click Get data from another source. In the OneLake Data Hub, find and select your LG_EVG2024 Lakehouse. If it's not visible, use the OneLake Data Hub button to navigate to it. From the Choose Data dialog, select the uploaded text file, e.g. verkoop.txt, and click Create to load it into DataFlows. In the DataFlow editor, perform any necessary transformations to structure the data properly for analysis and storage. At the bottom right of the data editor, now click the plus sign next to the data destination and choose Lakehouse. In the dialog box, connect to the Lakehouse LG_EVG2020, which is the same Lakehouse as which the original comes from. You can change data types if you need it, assign new names and types for simplicity. Before publishing, rename the data flow to import table. Now publish and run the data flow, wait for it to complete and ensure that the data is completely imported, refreshed and written as a delta parquet file into a table into the Lakehouse. Check the Lakehouse and the table is now ready to use in Excel or Power BI for reporting analysis. Microsoft has provided a consistent and powerful tool for data preparation across its ecosystems. The ability to store transformation data in different environments, especially the Lakehouse, gives users flexibility and speed, making it a top choice for Excel and Power BI users who want to manage large data sets efficiently. In the demo we use a Power BI query, but it works the same with the queries from Excel Power Query or Fabric Power Query Gen1. In the workspace EVG2024, use the button New Item and in the window choose for the button DataFlows Gen2. From the Home ribbon, get data and find the blank query to open the Power Query editor. Now open your Excel or Power BI model with the queries you want to copy to the data flow and select the query you want to copy. Right click and select Copy. The query, including all dependent queries, will be copied. Now close the source in Excel or Power BI and return to the Power BI editor in the data flow. If you use the right mouse button, click to find the option Paste, but that just triggers a message box. So use the old-fashioned Ctrl+V button to paste the query. The table with all its lineage is copied into the data flow. The data type was not set, so we add the query to the M language for the data type. And now it's time to add this table to the Lakehouse. Again, click in the right bottom of the editor screen and select the Lakehouse. Be aware that this option is only available when the table is visible. In the target window, all workspaces find the EVG2024 workspace. Fabric allows you to refresh your data model automatically, with normally a limit of up to 8 refreshes a day. This ensures you that the data is consistently up to date without manual interventions. The scheduled refresh feature is crucial because it automates the updating of your data models, which is essential for maintaining real-time or near real-time data insights. It's interesting to note that refreshes cannot be triggered directly at the Lakehouse level. Instead, each component that pulls in the data, like data flows, Python scripts, pipelines, must be equipped with their own refresh schedules and rates. This approach likely helps streamlining data operations to a higher level, ensuring that transformations and processes are handled with a specific context rather than requiring centralized refreshes. Find in the workspace EVG2024 our freshly data DataFlows import from web. Hit the 3 dots next to the name and choose from the drop-box down Settings. Click on Refresh, set refresh rate. Once done, use the Apply button . The medallion structure originates from the Databricks and is widely adopted in modern Lakehouse environments, including Microsoft Fabric. This architecture organizes data into 3 stages: bronze, silver and gold, with each stage serving a specific purpose in the data pipeline. In Fabric, this structure can be mirrored across multiple workspaces, each with its own user and permissions. Let's break down the medallion structure, bronze stage, raw data. The bronze layer is where raw data from various sources is collected and stored, typically in Delta Parquet tables. This data is only minimal transformed, such as formatting into Delta Parquet tables. Since this stage handles raw, unprocessed data, it is typically managed by IT or business units, professionals who have the technical expertise to ingest data from diverse silos and know how to handle large-scale storage. The silver stage transformed data. The raw data is transformed to suite analytic and business needs. This is where the essential cleaning, filtering and transformation processes are applied. Tools like DataFlows Gen2 in Microsoft Fabric automate the movement of data from the bronze stage to the silver stage and provides a user-friendly interface to apply necessary transformations. This stage is typically handled by advanced Excel or Power BI users or data analysts who transform the data into more redefined usable datasets. The last and gold stage, the business layer. The business layer is where fully transformed business-ready data is stored. This stage is optimized for end users such as business analysts and report developers who need ready-to-use data for their Power BI models, dashboard and other business intelligence applications. This is the workspace where final clean data is made accessible to a wider organization users for direct consumption in analytics and reporting without the need for further processing. Each stage is stored in a different workspace with unique sets of users and access rights. The bronze workspace is mostly managed by IT or data designers with unlimited access to other roles since it contains the raw, unrefined data. The silver workspace has a broader access, typically allowing data analysts and advanced business users to work on transformations. The gold workspace is an open and a wider range of business users that needs ready-to-use data for their BI models, without needing to worry about the underlying transformations. The medallion architecture helps to create a structure and organized flow of data where each layer serves a clear purpose. With available tools such as DataFlows, this process is completely automated and enables a clear division from IT professional to business users, making it easy for organizations to handle large-scale data, with ensuring that each role has access to the right data and the right time. This structured approach is particularly powerful for business users, enabling them to work with clean, well-organized data in their models, but with the possibility to adjust data to their changed need. In this final section, we cover how to import and use tables from a Lakehouse in Power BI tools like Excel and Power BI. The goal is to leverage the centralized data stored in the Lakehouse for analysis and visualization. In Microsoft Fabric, the way you connect and work with your data in the Power BI model varies depending on the platform and the type of connection used. One of the standout features is the direct lake connection. This option is comparable with the direct query option in Power BI. If you need more control of how your data is updated and you want to do ETL in your Power BI model or Excel model, you can use the SQL Endpoint API. These options allow you to bring the data from the Lakehouse into your Excel or Power BI as an import model. By using the SQL Endpoint, you can import the data and use scheduled refreshes. In Excel, you can connect with the SQL Endpoint and pull data into your spreadsheet for further analysis. Here's a guide to pull data from a Lakehouse into Excel using the SQL Analysis Endpoint. Start with retrieving the SQL Analytics endpoint from the Lakehouse. Open your Lakehouse in the EVG2024 workspace. Switch from the Lakehouse view to the SQL Analytics endpoint. Click on the settings gear icon top right of the screen. Scroll to the bottom of the About window, where you will find the SQL connection string. Use the button to copy the SQL connection string. The next step is to open Excel and connect to a SQL database. Open Excel, go to the Data tab and click Get Data. Select from Database and then choose the SQL Server database. Now paste the SQL Analytics endpoint in the server input box. You may be prompted to provide authentication details depending on your security setup. Looking in the database, now navigate and select the desired Lakehouse table. In the navigation window, a list of databases, lakehouses and tables available with the SQL Analytics endpoint will appear. Find the desired Lakehouse and expand it to view the tables. Select the table you wish to import into Excel. The last step is to load the table into Excel. Click the load button to import the table into Excel, and the data will be loaded into a worksheet as a structured table, ready for analysis. A note about the access requirements: SQL Analytics endpoint access. To use the SQL Analytics endpoint in Excel, users must have access to the Lakehouse. The SQL Analytics endpoint connector is exclusively available within the Lakehouse, meaning the user must have proper permissions to establish this connection. Steps to connect to a Lakehouse using the Power Platform connector in Excel. You do this by opening Excel and go to the Data tab. Click on Get Data, select from Power Platform and choose from Power BI. Now search for the Lakehouse. In the Power BI data source window, search for the name of the Lakehouse, and when you find it, select it and proceed. Select the table or pivot table option. You will see two options, table or pivot table. The table option imports the selected Lakehouse data as a standard Excel table. The pivot table allows you to create a pivot table directly connected to the data source. You should use this option if the table contains more rows than Excel can manage. The last step, choose the table needed and inserted it. In the dialog box labeled Create Table, select the desired table from the Lakehouse, click on Insert Table button and load the data into Excel. In addition to the SQL Analyze endpoint and Power Platform connector, you can also use the One Lake Hub connector to connect directly to a Lakehouse in Power BI or Excel. Go to the Data tab, select One Lake Hub connector, click Get Data, select from One Lake Hub and choose Lakehouses from the available options. Find and select the Lakehouses. In the One Hub Lake window, search for the Lakehouse you need by name. Once you find it, select the Lakehouse and choose the table you want to connect to. After selecting the desired table, you can load it directly into Power BI or Excel for analysis. For Power BI, this establishes a directory of direct lake connection, meaning the data remains live and is queried in real time whenever the report is accessed. In Excel, it will create a table or pivot table connection for real-time analysis. Thank you for your time and attention. I hope you enjoyed the journey through Fabric, and I look forward to your feedback and questions. Oh, and by the way, please give your honest feedback.